Okay, on to the second half of our Unit 4 review voiceover. Number 5 says, Tessa recently went to Bay Beach. While she was there, she rode some smaller rides that cost 2 tickets and larger rides that cost 4 tickets. So in all, she had a total of 50 tickets. So letter A says, complete the table showing some possible combinations of the number of each type of ride Tessa went on. And then B says, if Tessa went on 10 more small rides than the larger ones, how many of each type of ride did she go on? And explain your reasoning. All right, let's go through these. So the very first one, what we want to do is, let's look at our information we know. So she went on some smaller rides. Smaller rides cost 2 tickets each, and the larger rides cost 4 tickets each. And we know there's a total of 50. So let's use that information to come up with an equation. So we know the small rides in our chart are considered x, and our large rides considered y. So if we did this, small rides cost 2 tickets each. So it's going to be 2 times the number of small rides. And then we have plus. And y is going to be represented in large. And it costs 4 tickets for our large. So it would be 4 times y. I'm going to set that equal to 50 because that's how many tickets we have total. So we're going to use that information to solve and use it for our chart. So I'll zoom out a little bit. So in our chart, they either give us an x value, the small rides, or the y value, the large rides. So in this one, what we need to do is I'm going to use our equation, and we're going to substitute 8 in for my y value. So our equation is going to look like this. 2x plus 4y, or actually 4 times y, which is 8. They're telling us y is 8. And we're going to set that equal to 50. So it's going to be 2x plus 8 times 4 is 32 equals 50. I'll subtract 32 to get x alone. When we do it on one side, we do it the other. 32's cancel out, so we have 2x equals 50 minus 32 is 18. I'm going to divide by 2. My last step, x will equal 18 divided by 2 is 9. So if we went on 8 large rides, we have enough to go on 9 small rides. Okay, let's move on to the next one. This time we're using 12 for our y. So I'm going to use the same exact equation that we had before. So it's going to be 2x plus 4 times the large rides. Well, we know that we went on 12 of them. So I'm going to put 12 in for my y. I'm going to set that equal to 50. So nothing we can do with the 2x. Plus 4 times 12 is 48 equals 50. I want to get x alone, so I'll subtract 48 from both sides. You're going to notice we're not going to have very many tickets left. 48's cancel, so we have 2x equals 50 minus 48 is 2. And our last step, divide by 2. 2 divided by 2 is 1. So x will equal 1. So put 1 up there. In our next one, this time they're giving us our x value, and we have to solve for our y. So just for space-wise, I'm going to do it over, let's see here. Just wrote it out of room here. That's okay. I'll do it right here. So our first equation will be 2 times our small size. In this case, in our chart, they're telling us this is 25. Plus 4y equals 50. There's our equation. 2 times 25 is 50. Plus 4y equals 50. I'm going to get y alone, so I subtract 50. Subtract 50. 50's gone, 50's gone, so all we have left is 4y equals 0. We'll divide by 4, so y will equal 0. So if you went on 25 small rides, you don't have any tickets left to go on the big rides. So it's a big 0. Then our last one. Our last one, they're telling us there's 5. We went on 5 small rides. So I'm going to put 5 in for x. So our equation would be 2 times 5 plus 4y equals 50. So 2 times 5 is 10, plus 4y equals 50. Subtract 10. What do they do to one side, do the other? 10's gone on the left. So 4y equals 50 minus 10 is 40. Divide by 4. 40 divided by 4 is 10. Y equals 10. So I'm going to plug 10 into my table. Okay, we filled in our table. Now, part B reads, if Tessa went on 10 more small rides than large rides. So let's take a look at our chart. Right now, do we have any, right now they're saying you have to go on 10 more small ones, small rides than big ones. So we went on 9 and 8, so we didn't even get to do 10 on this. So we know it has to be more than 10 on the x side. So let's figure out what it could be. So I'm just going to use, let's try 15. 15. So I'm just going to test it over here. So if I use our same equation, and they said they have 10 more. So if I pick 15 small rides plus 4y equals 50. Sorry, we're out of room here. 2 times 15 is 30, plus 4y equals 50. I'm going to subtract 30, So we have 4y equals 20. Divide by 4, y will equal 5. So if we use 15 and 5, they're 10 apart. 15 minus 10 is 5. So that would work. So it says how many of each type? So you'd say small equals 15, large equals 5. There's our answer. So I'll zoom in a little bit for that one. Give you a moment. Number 6. In 6, we have A through E. So these 5, what we have to do, it says indicate which systems have a one solution, a no solution, or infinite many solutions. And explain how we know. So what we need to look at is, the easiest way to do this is making sure they're in slope-intercept form, or y-intercept form. That's why we want y equals basically slope-intercept form, y equals mx plus b. We want it in the same form. So in A, they're the same form. So what we're going to be looking at is, if it's one solution, we're going to look at our coefficients. That would be our m. If they're different, so they're different in this case, it's going to be one solution. So our answer is one solution, and I'm going to say different, let's say different slopes. And in other words, they're different coefficients. We call the number in front of a variable like that a coefficient. So they're different coefficients. So in this case, the coefficient of the first one is -2, and the other one's 3. -2 and 3 are different. Okay, moving on to B. All right, this one. We look at our coefficients. They're both 2. They're the same. So then, if we have the same, then we look at our back number, our B. If they're identical, which they're not in this case, these are different. That means these two lines are going to be parallel. So you could say no solution. And the reason how we know that, we say same coefficient and different constants. We call the numbers in the back, the B, constants. Same coefficients, a different constant. So that means they're just going to be two lines that will never intersect. They're like railroad tracks. C. All right, C and D, we're going to have a little bit more work to do. Being that, you notice they're not in slope-intercept form. So the very first step is, let's put them in slope-intercept form. So I want to do the top one first. X minus y equals -1. So I want to get y all by itself. So I'll subtract x, and x's cancel out there, so we have negative y equals negative x minus 1. Notice, I didn't combine those. I can't combine these because one has an x and one doesn't. So I just write them up horizontally like that. And this is still not done because we have a negative y. I want just a positive y. So I want to divide by -1. Negative and negative become positive. So when I do it at once, I have to do it to all terms. Divide by -1. So in this equation, simplified equation, we put it in the slope-intercept form. So negative and negative become positive, so it's y equals negative and negative become positive, x, and negative become positive, plus 1. All right, so there's our first equation in slope-intercept form. Now let's do our second one. We have 3x plus y equals 9. So I'm going to get y by itself. So I'm going to subtract 3x. So I do it one side, do the other. So 3x cancels out on the left, so we have y equals, perfect. And I can't combine those because one has x, one doesn't. So we have negative 3x plus 9. All right, there's our slope-intercept form. Y is positive, so I'm going to write them right underneath each other. So in this one, we're looking at our coefficients. When there's not a number in front of our x, we always assume it's 1. 1's there. So we have a 1 and a negative 3. They're different numbers. So it should tell us different coefficients. It's going to be a 1 solution. So I'm going to write it over here. 1 solution. And how do we know that? Different coefficients. Different coefficients. Because of that 1 and negative 3 are different. Some space here. 2 left. Once again, these aren't in slope-intercept form, so I'm going to do that. So I want to put x minus y equals 12. I'm going to put this in slope-intercept form. And this time I'm going to move my y. Plus y. So we have x equals y plus 12. Now subtract 12. 12's gone on the right. So I'm going to write it out like we normally see it. Y equals, now it's on the right side, now I'm going to flip it over to the left. That's okay. And I can't combine those two because one is x, one doesn't. So I just write x minus 12. All right, there's our slope-intercept form for the first one. Our second one, equation is negative x plus y equals negative 12. I want to add x to get y alone. X is canceled out, so we have y equals x minus 12. So I want to write this over here, right underneath it. You notice our equations are identical. Y equals x minus 12, y equals x minus 12. It's going to be the same exact line. So in that case, when you're graphing it, you graph this line, and then you graph this line. It's going to be right on top of it. So our answer will be infinite. I'll write it over here. Infinite number of solutions. It's the same line. Both of them. And then our last one, E. They're both in slope-intercept form, means that we have y all by itself already. We look at our coefficients, we have a negative 2, and then there's no number here, so we assume it's 1. Negative 2 and 1 are different, so it's going to be one solution, different coefficients. That's our reason. So when you're asked to do this on the test, make sure you're stating how you know. That's what different coefficients. You're stating how you know it's one solution or no solution or infinite number. Okay, then we have one last one on this page. It says solve the system equation, show how you reach your answer. So here we go, number 7. So we have our system of equation, and what I'm going to do is I'm going to zoom in here. So what I'm going to do is look at our two equations, and I'm going to look for one that has a variable all by itself on one side of the equation. So this one we have both on the same side. Go down here, we have y by itself. Perfect, so I'm going to use this. So they're saying that y equals 1/2 x plus 2. So they're saying this whole chunk here, 1/2 x plus 2, is what y equals. So I'm going to use that, and I'm going to substitute it into my top equation, right where the y is, because that's what y is equal to. So I'm going to write that out. So using our top equation, it's going to be 3x plus 4 times y. Now our y is this whole chunk, 1/2 x plus 2. And we're going to set that equal to 18. So I want to clean this up now. There's nothing I can do with 3x, so that's the same. Plus, now I'm going to distribute. 4 times 1/2 is 2. We have the x, 2x. Plus, 4 times 2 is 8, equals 18. I'm going to clean this up. 3 and 2 is 5x, plus 8, equals 18. I'm going to subtract 8, subtract 8. So we have 5x, 8's are gone, equals 10. 18 minus 8 is 10. Divide by 5, divide by 5. So x will equal 2. So ultimately what we want is get an ordered pair here. We have our x value and our y value. We know our x value we just solved, which was 2. So I'm going to put it here, 2. Now we're going to use that information to solve for y. So what you can do is pick either one of our equations in our system and substitute 2 in for our equation. I'm going to use our bottom equation. Doesn't matter. You can use the top one. You're still going to get the same answer. So I'll show the work over here. So I'm going to write our bottom equation now of our systems is y equals 1/2 x plus 2. So what I'm going to do is I'm going to substitute my 2 in for my x right there. So it's going to be y equals 1/2 times x, well, times 2 plus 2. 1/2 times 2 is 1. 1 plus 2 is 3. So y will equal 3. So we found out our x value and our y value, and I'll put it as ordered pair right here. So our ordered pair is 2, 3. So what does that tell us? So if we were going to graph this system of equation, we graph this line, then we graph this line, they're going to intersect at 2, 3. Lines will cross at 2, 3. Last page. Here we go. So I'm going to do a combination of things on this last page. So it says here is the graph of one of the equations in the system of two equations. The solution to the system is -3, -4. Select all the equations that could be the other equation in the system and explain your reasoning. So we've got to find all the ones that are going to cross at -3, -4. So we need to cross right there. So let's find that on our graph, our coordinate grid. So if we zoom in, to find -3, -4, I start at the origin. I want to go left 3 and then down 4. So this is where our lines have to cross, right at that point. That's -3, -4. If our line does not cross at that point, it is not a solution to this system. So we just got to test them out. So I mentioned I was going to do a series of ways to do this. So the very first one that I want to do on this is we're going to use as a substitution method. So we know that -3 is our x and -4 is our y value. So if we substitute -3 and -4 into our equation, let's see if it works out. So we have, I'll just write that, -3, -4. So we have our x and our y. So I want to substitute each one of these into our equation. So y equals, so -4 equals -5 times our x. Our x is -3. So -4 equals -5 times -3 is +15. Does -4 equal 15? Nope. So the first one does not work. So that's one way to do it. All right, let's try another way. Oh, let's just use the same way in this way. All right, so we have y equals 5/3 x plus 1. So I'm going to fill in what we know. Y is -4 equals, we have 5/3 times our x value. Our x value was -3. And this one, since that we're dealing with a fraction, I'll put it over 1, just to make things a little easier. And then we have plus 1. So there's nothing we can do on the left, so it's -4 equals. I can multiply across and then reduce, but I'm just going to reduce right away. I'm going to take a 3 out. 3 becomes a 1, -3 becomes a -1. So 5 times -1 is -5/1, which is -5, plus 1. -5 plus 1 is -4. So -4 equals -4. Yes! This one works. And there's not a ton of room, so I'm going to use the space on the bottom. So I'm going to write C down here. C. So we have y equals -16x plus 1. So I'm going to substitute -4 in for my y equals -16 times our x value of -3. I'm going to put it over 1 because we're dealing with a fraction. And then we have this plus 1. Oh, wait, I wrote this problem wrong. It's -16 plus 5. This should be plus 5. It's 5 plus 5. All right, sorry about that. All right, so if we figure this out, I'm going to take a 3 out. Oh, -4 stays the same. -16, so a negative and a negative become positive, so plus plus. I'm going to take a 3 out. 3 becomes a 1, 6 becomes a 2. And this multiply across 1 times 1 is 1. 2 times 1 is 2, so it's 1/2 plus 5. Well, -4 equals 5 plus 1/2 is 5 1/2. Does that equal? No, so this one does not. Let's do another one the same way, just substitution using our x and our y. So this time in D, our equation is y equals 2/5x minus 2. So y is -4 equals 2/5 times our x value of -3/1. And we're going to subtract 2. So there's nothing we can do on the left, so -4 equals, and there's nothing I can reduce, so I'm just going to multiply across. 2 times -3 is -6. 5 times 1 is 5. Then we have this minus 2. And in this case, -6/5 would be 1 1/5. So -1 1/5. Minus 2. We subtract that, and we get -4 equals -3 1/5. Is that a true statement? No. Answer's no. For our last two, we'll actually use our graph. So I'm going to write E down here. Y equals 1/3 x minus 3. So this time let's identify our m, and just like we did in past problems on this review, our m is the number that's our coefficient, so in this case is 1 over 3. Think of this as vertical distance of 1, horizontal distance of 3. And our b is, we got to remember to include the sign in front, it's negative 3. So what we're going to do is use this information and graph it. So first thing, I'm going to look at my b, our beginning point. This is where it crosses our y-axis. It's at negative 3. So I want to start at our origin and go down 3. 1, 2, 3. Make a big dot. Right? That's our beginning point. That's our b. Now, what we're going to do is look at our m. Our m is 1/3, 1 over 3. So it's a vertical over a horizontal. It means I'm going to go up 1, or I can go down 1, and actually that's what I'm going to do. I'm going to go down 1 and left 3. 1, 2, 3. And it is going to indeed hit right at our spot. Down 1, left 3, 1, 2, 3. You know, our slope is positive. It's positive 1/3. So overall, looking from left to right, it is going uphill, which means it's a positive slope. So, does E work? I want to label it E, and yes, it does. I'm going to write yes. And over here, just as a note, for your teacher, you can see C-graph. The reason why I didn't want to do all these is because by having six lines on this small coordinate would get too much. That's why I only decided to do a couple. And then our last one is letter F. Letter F, our equation is y equals 3x minus 4. Our m is our coefficient of 3. I'm going to put 3 over 1 to help us in our graphing. And our b is, we're going to look at the sign in front as well, so negative 4. So on that, I'm going to use that information to help us graph. So I'm going to look at my beginning point of negative 4. So go up to our grid, start at origin, and it's going to be down 4. 1, 2, 3, 4, negative 4. Put it down. Now from there, it's going to be a positive slope. So it has to go uphill, just like this. So I'm going to go up 1, 2, 3 over 1, up 3, 1, 2, 3 over 1, and we have enough. So I am going to make my line. And does it ever hit our intersection of negative 3, negative 4? No, it does not. So I'm going to label this one F. And down here, I'm going to write C graph. You're going to put a big no. It does not work. Well, that pretty much concludes our review. Good luck to you on your test.